Hello, welcome back to another uh, fun-filled math video. Today what we're going to be looking at, or at least in this video what we're going to be looking at, is what's called sigma notation. And I don't know if you've seen this before. It's possible you have, but I'm also not convinced that you have. And so basically, sigma is a Greek letter. This is sigma. Okay, it's it's Greek, and it basically just means sum. Okay, it's equivalent to sum. Okay, so when you're doing a sigma in an equation, it means you're adding things up repeatedly. And so the way that we write this in math is we'll do something kind of like sum. Well, maybe before I do that, before I actually show you how it's done, I'm going to show you kind of why we're using it. Because last time we had talked about our sequence of partial sums. And remember, the sequence of partial sums was I took, well, the first term of that, I just took the first term of the sequence. Then I did the first two terms of the sequence added together. Then I did the first three terms added together, right? And so on. And so kind of the idea behind the sigma notation is there's got to be an easier way of writing this mathematically without having to use dot dot dots, right, to kind of describe this pattern. Because like how do we write an equation for S sub n? Well, I mean, we could do a1 plus a2 plus all the way up to an, right? We sum up the first n terms of our sequence. But we kind of want to be able to do this just without the dot dot dot. Now, it's perfectly okay to write this, but in math we like efficient notation, and this is just a really efficient way of doing it. Okay, so how we use the sigma notation typically is I'll give you kind of an example of what you might see. So you got a sigma here, k equals 1 below it up to 5, and then maybe some equation here, so k squared. Okay, so what this means when you see this is, well, the sigma is a sum. Okay, so you're summing your k where it's appearing below the sigma. That tells you that this is the thing that you're summing over. So it's kind of like your n in this equation. You're going from 1, 2, all the way up to n. So k is how many things you're summing up, and you're going from 1 to 5. Okay, so the one at the bottom tells you where you start. Okay, so this is your start. This is your stop. So you start at 1 and go to 5, and you add together all your results, and you're adding up the sequence. Okay, so this is the sequence that you're summing up. So your sequence equation. This is the sequence that you're adding to itself. Okay, so how this would look when you actually do this out is you would start at k equals 1, and you would plug that in for k in the sequence equation. So you'd get 1 squared. Okay? And so you plugged 1 in and you got 1 squared. Okay? Now You're not to your stop point yet, which was 5, so you add 1 to k. So you add 1 to k, you get 2, right? That's the next number that you run into after 1. Okay, so 2 is the next number you run into. You plug in k equals 2 into this formula. Okay, so replace k with 2. It's 2 squared. Okay, we're adding it because it's a sum. Okay, then I do k equals 3. Okay, I haven't reached my stop point yet, so I plug in k equals 3 and I add that to what I had before. Okay, plug in k equals 4. Okay, add that to what I had before, and then finally we are stopping here up at 5, so my last thing in this is I would add 5 squared. Plug in when k equals 5 and add it to the other stuff, okay? Now I don't go on to 6 because this is where I stop. This is the stopping point of this, okay? So when I actually do out this sum, I have 1 plus 4 plus 9 plus 16 plus 25. Let's see, what is that? 14, so 30, so 55, I think. If I didn't make a mistake there. Yeah, I'm pretty sure 55. Okay. So this would be the same thing as this. It's just a different way of writing that you're summing up something repeatedly. Okay. So let's look at another example of this. Let's maybe move this. Okay, so another example. Let's look at the sum from j equals 3. Remember, this is your start up to your 5. That's your stop. And we'll do 1 over j. Okay. Now, it doesn't matter what variable you use in this. Normally, it's like I, j, or k. Those are typical letters that they use for, these are called indices. But yeah, it doesn't really matter. You could use x, but generally we like to use x when we're dealing with any real number. Here we're just dealing with whole numbers like 1, 2, 3, 4, 5, 6, 7, and so on. Okay, so what would this be equal to? Well, I'm starting at j equals 3. This is my start point. So I plug in j equals 3 into the equation, and I get 1 over 3. Okay. And then I'm going to add when I plug in the next number. So the next number is 4. I'm not to my stop yet. So if we're still at 4, we can plug that in. 1 over 4 added to, okay, my stop point is at 5, but I still plug that in. So j equals 5 is 1 over 5. Okay, so notice this was plugging in j equals 1. This was plugging in j equals, or sorry, not j equals 1, j equals 3, because that's where we were starting at. And this was j equals 5. So I'm just doing 3. We're going from 3 to 5, so 3, 4, and 5, we're plugging in and adding those answers together. Okay? So, what do I get when I do this? This is going to be kind of nasty to do. Let's make a common denominator here. So that's 4/12, 3/12, and 1/5. When we add those two together, we get 7/12 plus 1/5, Let's make a common denominator between these two now. So I'm going to times this one by 5 over 5. So we get 35 over 60 plus this one I'll times by 12 over 12. So 12 over 60. This would be 37 over 60 would be the sum. Okay. So again, sigmas just mean that you're adding something to itself repeatedly. Okay. Q. So I do want to do a few more examples of this before we're done, because I know this can be a little tricky and there's a few curveballs on the homework. So I'm going to do just a few more examples before we're done here on this video. Where's my eraser? Oh, there it is. Okay. Cool. So now let's look at an example like this. We have the sum from I equals 1 to 6. Okay. And let's just say I have a 2 right there. Okay. So again, what do these parts mean? This is the start. This is the stop, your last one, and then this is your sequence. Okay, so in other words, what we're doing here is I'm starting at I equals 1 and plugging in I equals 1 into this equation. But notice there isn't an I here, right? So it doesn't really matter what I is, it's going to be 2 regardless. So 2 is when I equals 1. Okay. Now we add 1 to I. So at I equals 2, what do we get? Well, again, there's no I in this. So just got another 2, right? Plus, we plug in when I equals 3. What do we get? Again, 2, right? Hopefully you can kind of see the pattern here. It's just 2 every time. Okay? Another 2 when I is 4. And we're not to our stop yet, right? Our stop is at 6. Another 2 when I is 5. And then finally, another 2 when I is 6. So in other words, how many 2's do I have? I have 1, 2, 3, 4, 5, 6. 6 2's added together will give me 6 times 2 is 12. Okay, so that would be my answer here. Okay, so it works too, even if there's not an I in the equation. You're just adding up that number basically 6 times to get your answer there. Okay. One last example I want to show you that's a little bit messier than the ones we were doing. So let's do, I'm going to do the sum from I equals 1 to 50 of -1 to the I power. Okay. So this one is kind of nasty because we have the start place is at 1 and the start place and the stop place is at 50. So we're adding up 50 numbers here, which is kind of crazy. But let's just kind of write out the first couple and we'll see kind of what's going on here. So when I plug in 1, what happens? When I equals 1, we get -1 to the +1 is -1. Okay. When you plug in +2, you get +1. Okay, you're going to be adding those together. When you plug in +3, well, -1 cubed is -1, so we're going to get plus -1. And then plus. Now, what do you think will come next? When we plug in I equals 4, we get +1, right? So notice what's happening here is I'm starting with a -1, and then I'm adding +1, adding -1, adding +1. What happens here as we sum these all up? Well, when we add up just these two, right? -1 plus +1 is 0, right? These are both 0, okay? So essentially what I'm doing is every 2 I'm adding 0, okay? So now let's just make sure where we kind of end up here as we keep going along this, right? We'll maybe do the last couple terms. When I do I equals 49, 49, what do I get? That's an odd number, so that's going to be my -1. And then when I equals 50, which is my stopping point, we're going to be at +1 again. Now notice it's always the -1 cancels out with the 1 after it, so these two here are going to cancel out to 0 as well. So essentially this whole sum here is just 0 because everything will be canceling out as you add this up. Even though it's a huge sum, right? There's 50 -1s switching to +1s, right? There's 50 numbers in this sum, but you can figure out the answer is 0 just by kind of looking at the pattern here. Okay, so hopefully this kind of helps with sigma notation so that you can get a bit of a handle on it. In the next video, we're going to look at taking sums like this that are kind of expanded out and writing them in sigma notation. Okay, so that's what we'll do next.